Hey everybody, here's problem set 1.4 key. I've already defined some stuff for you. Absolute value. Absolute value is the distance a number is from 0 on a number line. And that is why when you do absolute value of a number, the answer is always positive, because the distance must be a positive number. And then we have another definition here, extraneous solution. So an extraneous solution is a solution we find, and we do it accurately, like we didn't make any mistakes, but for some reason that solution still doesn't work. And we'll see those throughout the next few sections in Unit 1. So we're going to evaluate some absolute value stuff here. And then it says treat absolute value like parentheses in Pemdas. So like we're going to have to do the stuff inside the absolute value before we would do the number out here or any other numbers that happen to be on the outside. So absolute value of 4 is just equal to 4, because it means the distance 4 is from 0 on a number line. The absolute value of negative 8 is 8, because negative 8 is 8 units from 0 on a number line. Remember, this answer is a distance, and so it has to be a positive answer. Now, here we have to do this in order, so we do the absolute value of 9 first, which gives us 9, but there's a negative in front, so this one actually equals negative 9. Notice that the absolute value didn't equal a negative number. This still equals 9, but then there's a negative in front. So you can get negative answers, but not from the absolute value itself. Okay, and then on D, we just do 91 minus 107, which is negative 16, and then minus 4, which is negative 20, and then the absolute value of negative 20 is 20, because 20 is, or negative 20 is 20 away from 0 on a number line. Okay, same thing here. We're going to leave the 3 out there, do everything inside first. I'll do it step by step. We get negative 12 plus 33. And we get 3 times, that's 21. So absolute value of 21 is 21. So this is just 3 times 21, which is 63. And then the last one here, leave the negative 2 alone. We got to do inside first. So we get 31 minus 19. And so negative 2 times the absolute value of that is 12. Absolute value of 12 is 12. So it's just negative 2 times 12 is negative 24. So that's how you can get a negative answer even though we have an absolute value in the problem. It's because I multiplied by negative on the outside. And that's the same thing that happened over here. I mean, we technically multiplied by negative 1. Okay. So this says if absolute value of x equals c, and as long as c is a positive number is what this means, greater than 0, what does x equal? Hint, there are 2 answers here. And now maybe if you guys have never seen this notation, but c just represents some number, any number, as long as it's a positive number. So let's just do an example with an actual number. Like let's say we were going to do the absolute value of x equals 5. Well, how many numbers, remember absolute value is distance from 0, so how many numbers are 5 away from 0 on a number line? Well, 2 numbers, 5 and negative 5 are both 5 away. Or you can simply write it as x equals plus or minus 5. So in general though, if the absolute value of x equals c, where c is any number, then the absolute value of x equals c, then c, whatever this number is, that's exactly how many units that you are away from 0 on a number line, like your distance from 0. But then negative c is also the same distance away. So we can say x equals plus or minus c. No matter what c is, any number. So like if it was 5 here, then x can be 5 or negative 5, like we said. If it's 7, then both 7 and negative 7 are 7 units away from 0. So remember, absolute value means distance from 0. All right, so this question really says, what numbers are 18 away from 0 on a number line? Well, positive 18 and negative 18. Okay? So notice how we have kind of 2 answers here, 2 cases, because now it's going to get slightly more complex. And remember up here, I could write this as 2 different answers, x equals 18 or x equals negative 18. This is just a shorthand way to write that. But down here on B, I'm going to want to write 2 different cases. So I'm going to write them out separately. Like this is some number is 18 away from 0, so that number can either be 18, or we could have 2x could equal negative 18. Because this is, we're saying how far is this from 0, and we're saying it's 18 away. So it's 18 away from 0, it could either be 18 or it could be at negative 18 on our number line. Then we just solve these separately and find the x values. So divide by 2 and you get x equals 9. Or divide by 2 over here and you get x equals negative 9. Now if you check these answers, just by plugging them back in right here, so plug in 9, you get 2 times 9 is 18. Absolute value of 18 is 18. Plug in negative 9, and you get 2 times negative 9 is negative 18, and absolute value of negative 18 is also 18. So we got two different numbers that are 18 away from 0, and we were trying to find the x values that make that happen. And they're not always just going to be opposite of each other, so be careful with your final answers. You got to find your two final answers separately, and we're going to see a difference here in part C, where the answers aren't going to be just opposites, like one's positive, one's negative of each other. One might be positive, one might be negative. You could get two negative answers, you could get two positive answers, you could get one answer and then the opposite of that answer. There's all sorts of different answers you can get here. But in any case, so here we have, again, distance from 0 equals 18. If the distance from 0 equals 18, either that number could be 18 on the number line, or that number could be negative 18 on a number line. Both of these numbers, if you're negative 18 or you're 18, either way you are 18 away from 0, which remember is what the absolute value symbol means. So now we can solve these separately. Subtract 6, divide by 2, and you get x equals 6. Now I'm going to put the word or in between here, because these can't both occur at the same time. I guess I don't really need it until the final answer here at the end. But again, I'm going to subtract 6 and get negative 24. Divide by 2 and you get x equals negative 12. So now, if you take these answers, so take 6, plug it in right here, and you get 2 times 6 is 12, plus 6 is 18. Absolute value of 18 is 18. Plug in negative 12, and you get 2 times negative 12 is negative 24, plus 6 is negative 18. Absolute value of negative 18 is 18. That's why we set the inside equal to either 18 or negative 18, because either way, when you take the absolute value of it, since it means distance from 0, you will get 18 as your answer. Okay, same thing going on in D here, it's just the absolute value is written on the other side. So we want the absolute value to either be equal to 3, because then our distance from 0 is 3 if it equals 3, or we could have negative 3 equals k plus 7. Notice how I'm not setting the absolute value equal to a negative number. I'm setting just what's inside equal to negative 3, because if this equals negative 3, this number k plus 7 equals negative 3, then the absolute value of that number will equal 3. Okay, so we just solve this by subtracting 7. You get negative 4 equals k, or, oops, orange. And then subtract 7 here, and you get negative 10 equals k. So again, you can check, plug in negative 4 right here, and you get negative 4 plus 7 is 3. Absolute value of 3 is 3. Plug in negative 10, and you get negative 10 plus 7 is negative 3, but the absolute value of negative 3 is 3, because again, it's distance from 0. All right, this one gets slightly more complicated here. Before you can do what we've done on all these other problems, you have to get the absolute value by itself. So first we got to get rid of this 9. So subtract 9, and you get negative 4 times the absolute value of x plus 10 is equal to negative 24. Now we got to get rid of this 4 right here. So now we can divide by negative 4 everywhere. Divide by negative 4. These will cancel, which is the point of dividing by negative 4, leaving us with, we'll come up here, Now we have the absolute value of x plus 10 equals 6. So now we're looking for two x values in here, one that gets us 6 because the absolute value of 6 is 6, and one that gets us negative 6 because the absolute value of negative 6 is also 6. So now this is like every other problem we've done so far. We can set up two different cases where x plus 10 equals 6, or, oh, not that color, not that color either, or x plus 10 equals negative 6. Because then either way, the absolute value of this number or this number will equal positive 6. Okay, so all you do is subtract 10 over here and you get negative 16. On the blue one, you also subtract 10 and you get x equals negative 4. Again, notice how these two numbers are not the same by any means. Like one's not just 16, the other's negative 16. That happens sometimes like it does over here, but it's actually not going to happen more often than not, most likely. Okay, you can check those numbers by plugging them in. I'll save us some time and just tell you that they do in fact work, but you should check them because we could get an extraneous solution, which is a solution we find, but it doesn't work for some reason. So you always have to check these. All right, now coming down to f, this one's a little trickier because we have x's on both sides and like two terms over here, but everything's going to be the same. We're going to do 3x plus 2 equals 4x plus 5, or we've got to set up a second case here where 3x plus 2, the thing inside the absolute value, could equal negative this, because then when you do the absolute value of it, you get positive. So now you say equals negative 4x plus 5. Now notice how I use parentheses. You can skip a step here and just immediately write 3x plus 2 equals negative 4x minus 5. But you got to change the signs of both of these things over here because you have to distribute this negative. But if you know that, you can just jump from here down to this step right there. Okay, solving the blue one. I'm going to actually subtract 3x here. So my x stays positive, so I get x on this side plus 5. Subtract 5 and you get negative 3 equals x. And then doing the pink one, I'm going to add 4x, give me 7x plus 2 equals negative 5. Subtract 2 and you get 7x equals negative 7. And divide by 7, you get x equals negative 1. So now we have x equals negative 3, x equals negative 1. If you plug in negative 3, you get 3 times negative 3 is negative 9, plus 2 is negative 7, but the absolute value of negative 7 is 7. When we plug it in over here, we get 4 times negative 3 is negative 12, plus 5 is negative 7. But we get a negative over here, and you can't have that because the absolute value is always going to equal positive. So this is actually an extraneous solution. Extraneous solution. Plug it in. Plug it into the original equation and see if it works. I just explained that it doesn't. This is more somebody's reading the key. Okay, so that one didn't work. Now plug in negative 1, and you get negative 3 plus 2 is negative 1, and the absolute value of that is 1. Plug in negative 1 on over here, and you get negative 4 plus 5 is also 1. So now it's okay, because we got absolute value of negative 1 over here, and we got 1 over here. And so the absolute value of negative 1 is 1. So that solution worked. Okay, and now we're going to do inequalities. When solving absolute value inequalities, you still have two cases like we did in equations, but when you do the negative case, you got to change the direction of the inequality symbol. So two cases, I call it the positive case and negative case. The first one stays exactly the same, you just don't need the absolute value. Then you got to change, you got to say x is greater than negative 2. Okay, and then you just kind of decide, can this happen at the same time? Can x be less than 2 and greater than negative 2 at the same time? And the answer is yes. So this is where we can actually write it like this. We can say negative 2 is less than x is less than 2. So that's one way to write your solutions. We're going to write ours in interval notation, so we can practice that. So in interval notation, that is just negative 2 to 2 in parentheses. like that. Then you can also graph these on a number line, even though I didn't ask you to. Let's do that anyways. There is a homework sheet where I ask you to do it. So -2, 2, and that's where you go. So we have x is greater than -2, which goes this way. And then x is less than 2, starts at 2 and goes that way. And notice the open circles. Okay, so that's called an AND problem because both of these happen at the same time. Part B is almost the same problem. So you have x is greater than 2 for our positive case. Our negative case is x is less than -2. So that cannot happen at the same time. You can't be less than -2 and greater than 2 at the same time. So this is an OR problem, which if you remember talking about those earlier. So on a number line, that's where x is greater than 2 goes this way, but x is less than -2 goes this way. And that's when our interval notation looks like this. -infinity up to -2. Union symbol, if you remember that, 2 to infinity. So 2 to infinity describes this. -infinity to -2 describes that side. Okay? Next problem. Same thing. Just take what's inside the absolute value and let it be less than 12. But then we have to do a second case where x plus 4 is greater than -12. Subtract 4 from both sides to get x is less than 8. Subtract 4 from both sides, x is greater than -16. Can you be greater than -16 and less than 8 at the same time? Yes, you can. So this is where you can say -16 is less than x is less than 8. On a number line, it would look like this, -16, 8. So when x is between two numbers, it looks like that. And then in interval notation, it is -16 to 8, and they're both open in this case. Okay, so there's kind of 3 ways to write the answers. Let's box in the 3 ways. These are all ways to write the answers. And then these are all ways to write the answers to show all your solutions. Oops, it's actually all of this are appropriate ways to show your solutions there. All right, come on over here. Same problem, except now it's a greater than problem. It starts as greater than, this started as less than. So as long as x is over here and it's greater than, that's actually when it turns into an OR problem. If x is over here and it's less than, it's an AND problem. Notice how both of these were AND problems. So this one's part D is gonna look more like part B. But you don't need to memorize that, you can just think about it. So like when you get your 2 solutions, can they happen at the same time or do they happen separately? So first we're going to do x plus 4 is greater than 12. And then we're going to do x plus 4 is less than -12. Subtract 4, and you get x is greater than 8. Oops, subtract 4, and you get x is less than -16. You can't be less than -16 and greater than 8 at the same time. So this is an OR problem. On a number line, we have -16. Going that way. And greater than 8 goes this way. And this is where in our interval notation, so we're going to use put this in an interval that's -infinity to -16. And then you do a union, and then you show this, which is 8 to infinity. And so there's how you can write those answers. Again, 3 different ways. You got a number line, interval notation, or inequality notation. Okay. Part E. Same as before, 3x plus 6 is less than or equal to 18. Keep it the same. But then we also have 3x plus 6 is greater than or equal to -18. Now these steps are the same. You're going to subtract 6, get -24. And the red one, we're also going to subtract 6 and get less than or equal to 12. Then you divide by 3, so you get x is less than or equal to 4. Divide by 3 over here, and you get x is greater than or equal to -8. Can you be greater than -8 and less than 4 at the same time? Hopefully you said yes to yourself, because you certainly can. So that is where, on a number line, we would say negative 8. X is greater than negative 8, but less than or equal to 4. These are or equal to, so these are closed-in circles. All the other problems did not have or equal to, so we had no closed circles. And then as a single inequality, we would write it like this. And then in interval notation, that's when you start at negative 8 and you go up to 4 and you stop. And we have brackets because it's or equal to. So these are the 3 different ways that you could write your solutions there. And our last problem, we do 3x plus 6 is greater than 18. So again, it's the same problem as the one above, but it's the symbol's going the other way. So it's this E was an and problem, so this one's going to be an or problem. But again, if you don't know that, you just look at your answers at the end and see if they can happen at the same time or not. So we keep it the same, and then we do the negative case, so we switch the inequality symbol. Subtract 6, so you get negative 24. I'm subtracting 6 over here as well, leaving us with 12. Divide by 3 to give me x is greater than 4. Divide by 3 to give me x is less than negative 8. You cannot be less than negative 8 and greater than 4 at the same time, so this is an or problem. So we're just going to say or right there, and then x greater than 4 is here and goes that way, and then negative 8 is here and goes this way, and then in interval notation, oh, that's really misaligned. In interval notation, we go negative infinity to negative 8, open parentheses on everything there, union, and this starts at 4 and goes on forever, so 4 to infinity. And those are all the different ways you can represent the solutions to an absolute value inequality. All right, hope you learned a lot.